Hey guys, this is Coder Jeet, your best friend in programming, and today I'm going to talk about Blazor Webassembly server communication. Now you already know that there are two flavors to Blazor, the Blazor Webassembly and Blazor server side. Blazor Webassembly does all the work on the front end, and Blazor server side does all the work on the back end. Even the browser display code, when you click on a component, something happens on the browser, all of that is dealt with in the backend too, and the changes are communicated to the browser using SignalR. So basically, because all the browser work is done on the backend too, you can directly connect to your controllers, you can connect with your database objects and retrieve them in the front end, which makes programming very easy. But it's not the best way to program if you're going to make a public facing app which is going to be used by hundreds or even thousands of users, because Blazor server side is not scalable. Blazor WebAssembly, on the other hand, is entirely scalable. You can have thousands of users without a problem, but it's a little bit trickier to code because Blazor WebAssembly does everything on the front end. So all the code runs on the browser, all the code is viewable. Anybody who's your user can see the code and can see how you are coding it, and that's not a problem. That happens to every JavaScript based front-end framework too, like React or Vue or any other framework for that matter. And it happens to Blazor too, because Blazor is a front-end framework, and you cannot connect to databases directly because you are on the browser. Blazor does not connect to a backend database from the browser. You can't even put a connection string and connect to a database, and even if you could, it would not be advisable, because when you have a connection string on the front end, people can discover it and hack it, and that's a big problem. So you need a backend API to connect with Blazor WebAssembly. So when I started to write code in Blazor WebAssembly, I had to overcome these obstacles. The first is keep data secure, how to handle passwords and connection strings, and how to secure every single call to the backend API, because when you do have a backend API, which is basically just a REST API which emits JSON, anyone from any place can connect to it and call the methods on it. So what do you do to make it more secure, especially if the API is on another server or even on Amazon or any other cloud network? What would you do? How would you make sure that only authorized actors can access data? Well, that's what I'm gonna show in this video. So pay attention, because this is going to be the core of your Blazor WebAssembly project. This is the boilerplate basic app that you will get when you create the new project. This is the standard app that's set up for you, and it's got some clues about how Blazor works. There is a counter, and if you click a button, the count increases, and there is fetch data, and this data is actually obtained from a server. If you look at the app itself, the code, here's what you will see. This is one of the components, and the structure is there is a client app and there is a server app. The server app has one controller which has a get method which is being called by the client app to get this data. Now, how is this information being called? Let's take a look at that. So coming back to the client app, when you go to the programs.cs, this is where your app is set up initially. This is where the app is being built. There is a line here that says builder.services add scoped sp equals to new HTTP client. Now this is a dependency injection right over here of a HTTP client object inside your Blazor pipeline. This is a scoped service and HTTP client object. This HTTP client object is going to be available inside of your entire application, either using constructor injection, or when you look at a component, then you're going to use the inject directive. So at inject HTTP client, and then you give it a name. So this is going to be available all through your code. And here you will see, if you go to the fetch data component, there is a call to await HTTP get from JSON async, and they are using generic, so it's a weather forecast object. So you're gonna get a weather forecast object right over here, and it's calling weather forecast controller. The get method is right over here, and the data will be returned from this method. Let's give it a check by putting a breakpoint over here and running this again. So coming back to the code, let's run it again, refresh it. And now we'll click on fetch data, and you can see the breakpoint is hit. The data is coming from this method, and this can be on the website somewhere. It can be on the same domain where you're loading this client, or even on a different domain, and it will still run. Now this structure that they have here is functional, but it's very basic. You can't really create an entire app with just this code, with the HTTP client objects that's set up like this and just used in controllers like this. That's not an ideal setup, and you cannot make anything above a non-trivial application like this. So I'm going to show you how exactly I structure it to make a complete application that is secure and that works as designed. Before we go to that, let's identify the core problem. The weather forecast controller over here is not protected. Any service, any website can call this particular REST method and it will return the data. Now, if you are creating a SaaS product or a website, you would not want the data to be available to just about anybody. You will want to secure your application, and that's not being done over here. There is no code to secure the app. And in a Blazor app, which might have multiple controllers and even other data points, this can become a big problem fast. And how are we going to solve it? So there are a couple of things that you need to keep in mind. First, now this is more performance related. Use one HTTP client object with dependency injection. That's exactly what was done in this app, even programmed by Microsoft as a sample. There is a HTTP client object over here. That object is going to be available in all your project from this location using dependency injection. It's gonna be just one object. Now, HTTP client is designed in a manner that it is by nature asynchronous, and it handles threads properly. So when you make even multiple requests to HTTP client, it will automatically queue the requests and return them as soon as it gets the response, and without causing major overheads. However, there is an overhead involved every time a new HTTP client object is created. That's why Blazor is trying to create only one object for an entire app, for the entire application. Now, if you were to create separate instances of HTTP client, like instead of using injection, you wanted to create an instance of the HTTP client in this particular component, you could do that, but it would mean the object would instantiate again, and if you make multiple calls, that would keep happening and it would slow your application down. Now, you could be tempted to do this in a class that you create, because dependency injection is something that you need to implement from the first line of code that you see over here, and it needs to be carried on forward in all your classes in the same manner. So you might be tempted to do that if you're having any kind of model logic or classes inside of your Blazor app, the client app, and you might want to connect to the backend service by creating a new HTTP client object. I just want to remind you to avoid it. Use dependency injection and make sure it's the same HTTP client object all through the website. The second point is you will need to identify your app every time you connect to your backend service. And once you have authorized your user, once you have authenticated your user, you will also need to make sure that the app also recognizes which user is this data coming from. So all of that has to be done in a fashion that you don't write your code again and again. And that's what I'm going to show you in the rest of the video. So I'm jumping right into the code of the application that I'm programming right now in Blazor. And I've got the structure laid out in this manner. So the first thing, of course, you need the HTTP client object, and I am creating it, but I'm also feeding it an app name. So this is going to be a configuration object. If you go into your app settings, you can configure your Blazor project by going into www.root and app settings. So I'm getting an app name from the app setting, and I'm also getting an identity. So this is nothing but a GUID that I'm getting here from the configuration file. That's the identity. So every time I make a call to my backend API, the basic data that I need to give it is the application name and identity that is a part of this configuration file, and also a part of my server configuration file. So I have the two matching values. The server will return data only if it finds these two matching values in both the files. So this actually prevents casual REST calls to your endpoint. So you have open endpoints on the web with the server project. You don't want people to casually discover and call them, so you lock them up with app name and identity. Now on the server, how do you detect this app name and identity? You're making it a part of the HTTP client object. Look at this code. You create a new instance of HTTP client, and I'm adding two headers, the app name and the identity, which are a part of this HTTP client standard object, which then I will add to the builder. Now on the server, all my controllers inherit from a core controller, from a base controller, where I'm going to look for this identity and app, site identity and app identity, and only if they match, right? If they match the identities that I'm getting from the headers, only then I'm going to process the request. If it's not matching, then I'm just going to return an unauthorized access message, and the code will not execute. So this is the basic protection to identify your app. Make sure that the request that you're getting from the client is actually the app that you expect. Now let's look at the other two services that I'm adding over here. And the second thing I've got here is very important. It's the model, and I am adding the entire model as a dependency injection service, which will be available to all the code inside of your client project, including all the classes and the view too. Now this is important because the other project that we saw from Microsoft as a sample, what has it got here? All the processing code is written in the client side itself, like this particular code to get the HTTP data is written in the code, and that's perfectly fine for this little application. But if you are creating an app that has many different components, many different objects, and they're all communicating with each other, programming in this fashion is not efficient at all. Imagine having 5 different views or components that access the same data, may be presented in a different format, and then having to repeat one single function 5 different times in each component. That's not doable. That's a total violation of the dry principle of programming. Dry. Do not repeat yourself. If you've written one piece of code, you want to make sure that this same piece of code is used in all places where you need to process that code, or where you need exactly that particular routine. And you cannot do that if you use the model that was suggested in the sample application. So never do that. What I've done instead is I have created a model. Again, in this case, there is a base model class which kind of builds up the HTTP client object that we got. And I talked about constructor injection earlier. The object that you inject in programs is going to be available in your views using the inject function, using the inject directive. So when you go here, you can see an inject directive for the client. But inside the classes or inside the model that you've set up, you don't have the inject directive. What you have is constructor injection. So when you create a new instance of the model base, for example, over here, you are passing in the values, you're passing in the objects that you injected, the HTTP client object and the storage object. We will come to it in a moment, which is now going to be available inside your class. So you just basically assign it to a public property or a private variable, whatever you want, and then you can use it in all the functions inside your class. Now what I've done here is I have set up the model based object to have an access token and a user ID. Now these two things are available only when you log in, or only when the user logs in, and I will come to that in a moment. Basically, for now, you want to understand that all the classes in my model are inheriting from the model base. So for example, take the user class. It is inheriting from the model base, and if you look at the code, it uses the HTTP client object in the constructor injection, and then you've got functions like verify password or get user or update user. All of these functions have pre-filled values of the access token and the UID, because we put that in the model base. So in the model base, these two header values are already put in. I am using headers for all my data transportation. You can use form variables if you want. I just like headers better. Now what I have in the base class is a create request method which will return a HTTP request message pre-filled with the access token and the user ID. And I'm going to show you exactly how we get this in a moment, but just see for now that it is being read from the browser storage. So in this particular project, I'm not using cookies, I'm using web browser storage, for which I have created a storage class. Again, I am injecting it in programs.cs, and it's available to all the different parts of the program using constructor injection, or in the component using the inject function, the inject directive. So over here I've got storage class over here thanks to the constructor injection, which I'm using to read the access token and the UID that I have already stored. Now, how do I get this access token and UID? For that, I have one particular class called the auth class, which does not inherit from the model base. The functions in the auth class, these functions are called by the login component. This is the login component, and this is where the user fills in the email and the password, and the user and the password are verified against the server API in the auth controller. So in the auth controller, you've got get access token function where the user password and the email is verified with the database and an access token is returned. This access token is then stored in the browser storage. This is the user login function where I'm passing the email and the password to the server, getting an access token over here, and then saving the access token to the browser storage. Now with every subsequent request to the server for any other data than the actual access token, for example this one, the app must send the access token alongside. So to make a request like verify password or to get user data, the app must send the access token, which is handled by the model base, which every single model class inherits from. I'm giving you the step-by-step roadmap for this. The first thing, in the client project program CS file, add the HTTP client object with an app identity header. So when you create your HTTP client object in programs.cs of the client project, make sure you also create an app identity and pass it along with your every single HTTP request to the server. And at the server, make sure you check for this app identity, make sure it matches the value at the server before you process any request. Then when you log in, when your customer logs in, the user logs in, generate an access token and return it in exchange of the user login and password. So if the password matches, generate an access token and return it to the client. The client will then store this access token on the browser using a cookie or a browser storage. It doesn't matter, it can store the access token on the browser. Then in every subsequent request, this access token must be returned to the server. So if you want to process any data, like you want to modify any records or you want to get fresh data, the access token must be passed to the server so that the server can recognize that the user is valid, that the user ID, that the browser is authorized to get access for that particular user. And you can't store the password on the client side. So you always store an access token that's generated, and every time the user logs in, you have to generate a new access token. So what you're going to do now is to handle all the data that you're processing inside of your client project. Don't process it in the components. Create model classes. You've done MVC before. I hope if you've done model view controller before, you already understand the concept of model. It is where the business logic of your application goes. The components must only deal with the display. They should not have a lot of business logic inside the component. This is kind of like a MVVM layout, where model model layout, where the component is actually the view and the model class that you create could be the view model. So in the view model or the model class, whatever you want to call it, make sure that you're inheriting from a single model base, and inside the single model base you've got the access token as a part of your HTTP client. Let me show it to you again. This is the model base. I have a function called create request, and in that particular function I'm returning a pre-created HTTP request message with pre-fed access token and user. They are being retrieved from the browser storage. So you have to make sure that all the model classes that you have inherit from this model base, and to create a HTTP client request, they always call the create request function of the model. So let's go to users, for example. What it's doing is it's calling the create request function from the model base. If you right click on it and click go to definition, you will see that this is the model base function that we created earlier. So we are adding on the fresh arguments that we have as further headers, and then calling the server APIs to get the values. So in all your models, use the create request function of your model base to create the initial HTTP request message, and then add your further arguments as headers before making the HTTP client request. Now that is exactly what I did to create the framework for this application that I'm creating now, and it maintains all the requirements of a professional app. It's secure, it's fast, and it does not expose any of the user data to an unauthorized party. If you want to see exactly how this project is structured, I can make a GitHub repo with a basic structure, with a basic boilerplate for this project, and make it available for you. And I will do that once I hit 20 likes on this video. Just want to justify the effort that I will need to put in. So if you found value in this and you want to simplify your Blazor programming journey, hit the like button, and when we reach 20 likes, I'm going to create the GitHub repo of the boilerplate code for this entire framework and make it available for you. Now again, I am going to create a huge number of learning videos with a professional point of view to help you become a better programmer. So don't forget to hit subscribe and like this video, and encourage me to create more content. I know this video was more complicated than my most other content, but I really had to get this out because just knowing the technology is not enough. You need to know how to implement it correctly. And with Blazor, it's a very tricky situation because you are talking about a framework that is 100% client side, and you need to communicate with your backend code only through the API call. So you need to structure it correctly. That's what we've done in here. So go ahead, watch it as many times as you need to understand this concept, and hit that like button before you go. This is Coder Jeet, your best friend in programming, signing off.